Alright, so I'm going to make a final video before I go on my holiday. I'm going on a holiday tomorrow, so I won't be making a video for a while. And I know I haven't made a video in a while. It doesn't matter. This isn't my full-time job. Nobody cares. I've only got 21 subs. So, I'm going to solve a second order differential equation. When I return, I'll make videos on all kinds of differential equations, how to solve even tricky example. Yeah, whatever. So, and teach the concept of partial derivatives, which is like the easiest thing on the planet Earth. So, I have y double dash, I have minus 5y dash plus 6y is equal to x squared. So it's not equal to 0 in this example. It's a little different. Doesn't matter. So I start off by pretending it's equal to 0. So that's called the complement solution, I'm pretty sure. Or general solution. So that is going to be equal to, this is how I do it. So it's going to be lambda squared, just like I did it in the other examples, minus 5 lambda plus 6 equal to 0. And we all know that lambda is just going to equal to 2, lambda 1 and lambda 2 is equal to 3, which means that yc is equal to a e to the 2x plus b e to the 3x. We already know that. And if you don't know that, just watch my or anyone's videos on differential equations, but mine in particular, on how to find the general solution. I've got like 2 or 3 videos on it. Doesn't matter, I'll make more. So this is the general solution. We have an actual entire solution. Because we've got x squared here, we have to find a particular solution. So y is equal to yc plus yp. Now, I need to find out what the particular solution is. So yp is equal to, see this x squared here, on this x squared here. There's a rule for all kinds of, so whatever's on this side of the expression, you'll have a certain rule on how you would write the particular solution. But for the case of a polynomial x, such as x squared, I have to write for completely new constants. I can't use a and b now because they're independent. So these have their own new constants, just as the same as a and b have their own constants for the certain lambda. So for this case, I have to write c, and this is how you do it with a polynomial of x. So I have cx squared, just because I have the x squared here, and I write it all the way until I just have a constant. So I take the power down and I write a new constant coefficient that I don't know until I get to just a constant, and then I'm done. So what I do now is I take the derivative of this, and I'll explain why I'm doing derivatives of this in a second, but and then I take the derivative again, which is just 2c, and the reason why is because I have to sub this into my original differential equation. So whatever y double dash of p is, it's going to go where y double dash is, and where y dash is going to go, it's going to go and be factored inside where this y dash is. So without further ado, we're going to do that. So 2c minus 5, 2cx plus d, and then plus 6 times y, and y is cx squared plus dx plus e is equal to x squared. So what I have to do now is I have to correlate the coefficients with each other. And if you haven't done partial fraction decompositions and found out the constants, or partial fraction integrals, you probably be best to revise that. This is a pretty neat skill to be. It's not hard. I'll explain what I'm doing. So I have an x squared on this on this side of the equation. So I am going to equate all terms on this side of the equation just equal to x squared, and that's just an equation. So I've only got one thing that's x squared, so that's 6x cx squared. So you can imagine that the x squares on each side would cancel out. There's an imaginary 1 here. So 6c is equal to 1. And then c is just equal to 1 over 6. Cool. Now, I don't have anything else, but I technically have a 0x and a plus a 0c, which is just a constant, but I shouldn't write that. Plus 0, I should write. I technically have these things, And the reason why I say that is because now I'm going to equate the x's to the x's on that side, but it's just going to be equal to 0. So I have an x term here and an x term here. So I have to do minus 5 times 2c. Well, that's minus 10c. And then my other x term is 6d plus 6d is equal to 0. So I now have to solve for d, because I know c. So 6d is equal to 10c. And that means d is equal to 10 over 6. I'm just going to make sure if I've got this right. Yeah, I only have one x term, two x terms, yep. Alright. Minus 5 times 2, cx, yep. Correct, so yep, so d is equal to 10 over 6. So now lastly, I need to solve for my e, because that's the last constant I don't know. And if you're wondering why I haven't solved for a or b, it's because I can only solve for those if I have initial values or boundary conditions, which I haven't set for this particular problem, because it's just an initial problem. So now e. Now for e, I need to equate it to 0 as well, just the constant of the other side. So I have 2c, and I have minus 5d, because that's also a constant, and then plus 6e is equal to 0. But I know d and I know c. So c is 1/6, so this is just 1/3 minus 5 times 10. So it's minus 50 over 6. And then that's plus 6e is equal to 0. So, what next? So now I solved for e, right? So it's going to be 50 over 6 minus 1/3 is equal to 6e. I hope that's still on the page. And I can't be bothered, you know, doing the lowest common denominator, so I'm just going to do that on a calculator. Minus 1/3. And that's just directly equal to 8. So 6e is equal to 8. And then e is equal to 8 over 6, or e is equal to 4 over 3. I know that's like the worst handwriting in the world. So, what now? I know all my constants. And if you recall the original final answer, y is supposed to be equal to yc plus yp. So, I'm going to write my final answer here. So, y is equal to yc, and I know that was ae to the 2x plus be to the 3x. And now that's plus y sub p. But recall, y sub p is this. But I didn't know the constants. But now I actually do. So I can just plug in the final answer literally right now. So that's plus 1/6 x squared. And then plus dx. And that's 10 over 6 x. I haven't actually simplified that, I can, but it doesn't matter. And then plus e, and e is 4/3. And that is the final answer. So yeah, that's how you solve second order differential equations when it's equal to a polynomial of x to the n. So yeah, thanks for watching, and I won't make a video for another 2 weeks, unfortunately, maybe a bit longer, but I will make pretty much every, like, I'll make so many videos on differential equations, Laplace transforms, Fourier series, don't you worry. See ya, the video's very long.